Yeah, welcome everyone. We have quite a good attendance today. That's very nice. Few people still join. Okay, we will start now because we have a lot of slides to cover. So I'd like to take as much time as I can. Welcome again to this webinar on DevSecOps in GitLab. My name is Sander Brine. I live in the Netherlands. I'm Customer Success Manager for our strategic enterprise accounts within GitLab in the DACH region, the German-speaking region. Before we start, a few housekeeping options. First of all, if you have any questions, please use the Q&A button on the bottom of the screen. There's a Q&A option there, and there you can add answers, questions, and we answer it either live or through the chat. The webinar is being recorded, as you've heard, so the recording will be sent to your inbox in the next couple of days. And in the end, we'll have a poll to ask your opinion about this webinar. Awesome, thanks everyone. And let's get started with this webinar. First of all, what are we going to cover today? If we look at DevSecOps, DevSecOps is about adding security to your DevOps teams. So, in fact, making sure that security is as close to your development and operations teams as possible. And with end-to-end application security, you need a few things to automate. For example, application security testing and remediation, or policy compliance and auditability is something that you want to automate. But also production application protection, so protect your application in production and secure your platform where all your secrets can live, etc. In this webinar, we're going to focus only on how GitLab secure capabilities can help you find and fix vulnerabilities, and how GitLab's managed capability help you meet your compliance needs. I see a question coming in. What does DevSecOps mean? DevSecOps, DevOps is an abbreviation of development and operations, where we put development teams and operations teams together, more closely together, and they are together responsible for deploying the software into production. So it's not purely an operations responsibility anymore, but also a development responsibility. And with the sec in the middle, we add security to this DevSecOps, to these DevOps teams. And this is what you see currently in the paradigm of shifting left security. What you want to achieve, and I'll explain that more in the presentation, is you want to add security to your DevOps team, or at least more closely to your development organization, rather than having separate InfoSec teams doing all of the security assessments. Okay. That's a bit of understanding. So this is not about DevOps. This is more about our security capabilities within GitLab. And why is that so important? If you look at how much it will cost you if you want to solve vulnerabilities later on in the process, and you see that the cost will rise exponentially. So if you have a production environment and you want to fix a vulnerability there, it can cost you as much as 30 times more as you would do it early on during the requirements or coding phase. So the earlier you find vulnerabilities and the earlier you can resolve them, the cheaper it will be. Then what you see in many organizations is that they have application security in place, of course, but it's mostly done by InfoSec teams with application security tools that are fit for those situations. Traditional application security teams were built 10 or more years ago, and before we even thought about what DevOps was or that we do daily deployments. The industry needs to get beyond the simple shift left of giving development a light SAST, static application security test in their IDE, which was common in the past. You have like this code quality test or static analysis test in your IDE that gave you local results. But we want to lead a new era where security is baked into our software development lifecycle with a single application that is purpose-built for the modern software factory. And we see DevOps really taking a lift, and we also see that having one platform, one tool to build everything and to be in full control helps you stay in context. If organizations want to shift left security, they need to rethink current tools that target both dev and sec teams. So DevOps is about breaking silos, as I said. You want to add security capabilities inside of your dev organizations and have them work together. With the growing importance for security organizations need to scale security because organizations scale too, they grow constantly. Software is more and more important, and this can only be done by empowering developers. Development teams tend to scale much faster than security teams. It is our vision that developers play a major role in finding and solving security vulnerabilities at an early stage. That's what DevSecOps is all about. This means that application security tools is running early and often automatically triggered by a build pipeline. DevOps is about improving your deployment frequency. So if you have multiple deployments a day or a week, you also need the security tooling to run as often as that. Legacy application security tooling is often usage-based priced. So your license is based on how often you run the tool. And in that way, organizations are penalized for scanning more and more often. InfoSec teams are also still often the owners of application security tools, which brings the results of security vulnerabilities outside of the scope of developers. DevSecOps doesn't scale without developer enablement, automation, and exception-based security. InfoSec teams need to rethink their approach on security scans adapted to the modern way of software development. Let's look at how a current traditional application security silo works oftentimes. So we see a developer committing to a repository, then the merge request is merged and the deployment is running against a test environment. With traditional application security tools, these SAST or DAST, the dynamic application security tests, run against an existing test environment. A dynamic application test has to have a running environment to test against, whereas a static analysis test can run on the code base itself. But you often still see that these DAST test reports are sent to security teams, to InfoSec teams, and they dismiss the vulnerability or create an issue, which is then sent to the developer. And often you see that developers have gone on with new tasks and completely forgotten, but then they have to go back into context on what was this vulnerability about again. So if you can improve that, and let's say, hey, if you want your developer to stay on top of your vulnerabilities, if you can scan your code for security checks every time seamlessly for developers have it built into their build pipeline using fewer tools, and with all of these teams on the same page with the same requirements, then you also have happy compliance auditors, right? GitLab enables this by offering one application that spans the entire software development lifecycle, and that includes application security tests. We are uniquely positioned to truly improve the workflow of both dev and application security. This is our DevOps lifecycle as we see it. And with GitLab, all of these tests, so the SAST is the container scanning, dependency scanning, sequence detection scanning, and more, are automatically run with every merge request. You no longer need to choose between risk, cost, and agility. Because it's one tool for the entire software development lifecycle, you can use it on every code commit. All of these tests are running with every code commit automatically. I'll show you that later. The GitLab application creates a complete review app live with every merge request. So dynamic testing can be run on this working code as well, all very early in the software development lifecycle. There's no need to buy separate single solution tools. And if you already have such single solution tools, then you can reduce cost by using them sparingly with using GitLab for every code commit. Each of these scans, of course, have a lot of vulnerabilities, or may have a lot of vulnerabilities, especially the first time you run it. What would you do if you find more than 10,000 vulnerabilities at the end of your software delivery lifecycle? Does this create new liabilities for you? If you can't fix them right away, are they now an even greater liability because you know they exist? With GitLab, you can automate the software factory to apply the policy that you require. Now you can focus on the exceptions, not on managing spreadsheets or long lists of vulnerabilities. A lot of questions coming in, which is great. In one of my previous slides, it said EAST. That is, let me go back a bit. What's the difference between EAST and DAST? It was on this slide, it said, and EAST is interactive application security testing. That's in fact a way of instrumenting an application where the app could be automatically tested for security vulnerabilities while QA tests are done in the meantime. The intent is to enable developers, but a working test application is still required. And you need to instrument the application, of course. With Dust, you don't need to instrument the application. Dust runs from the outside, looking at an application as a sort of a black box. And they're running different dynamic tests on things like APIs or web frontends. There's also API fuzzing tests and other similar dynamic tests that will also run against a review app, for example. Let me go ahead again. So how does GitLab shift left on security? Let's look at what we see as a typical workflow for applying security. So with GitLab, you can run all of your security scans before the code is even merged. As I mentioned earlier, what does it mean before the code is merged? So if you look at a typical workflow for a developer, then developer will commit something to the GitLab repository. That commit will trigger a CI pipeline. And throughout the CI pipeline, security scans are run and also a review app is deployed. Against this review app, the dust scanning can run, and on the within the CI pipeline, all other scans like secret detection and SAST scanning are running. So within that merge request and within that commit, the developer immediately has a security test report. And based on the findings in that security test report, he can either fix a vulnerability, dismiss it, or create an issue for it. That way, when an issue is merged, vulnerabilities might not even get into the team of the security environment, the InfoSec team. So the InfoSec team might not even see the vulnerabilities that the developer already resolved in the merge request. And when a application is deployed, and then the security team can see after the merge request is merged on a security dashboard which vulnerabilities are left, and they can still dismiss or create issues on those remaining vulnerabilities. So the key to GitLab's approach is scanning the code at the point of code commit, so early as possible, before the code changes even leave the developer's hands. The developer can then iterate and add more commits to fix vulnerabilities, or with certain compliance workflows, they can ask for approval by an InfoSec team to approve a merge request before moving on. In the pipeline, you can run many different tests. We've already briefly seen them. So SAST is static application security testing, which detects vulnerabilities within the source code. Similar is infrastructure as code scanning, which also checks for vulnerabilities in the infrastructure code, like Terraform or Ansible scripts. Other more static scans are secret detection, which checks for passwords, credentials, also private keys, etc. in your code. And dependency scanning is also quite static, which tries to build a software build of materials of all your dependencies that you are using and checks that against the CVE database. License compliance is more like a compliance framework where you can allow certain licenses or not. You can also block certain licenses being used, and then if a dependency, for example, is using that license, then you get a warning out of that. Container scanning is running also rather statically against container images and not running containers. That other one might be something that's coming soon, but for now we are running against images. But then you have several more dynamic scans. So coverage guided fuzz testing detects unexpected behaviors at program method level. So you have like a sort of instrumented environment, and Dust and Web API fuzzing are tools that run against a running test environment, a running review app, and they check for certain vulnerabilities inside of that application. How does it look in a pipeline? So if you use, for example, Auto DevOps, you have a build pipeline that can look like this. In the build stage, you run build, and then in the test stage, you run all the tests. This can be or is typically on merge request level. So the container scanning, dependency scanning run in the test stage. Then a review app is deployed, and the Dust scan and potentially the Web API fuzzing test run in the Dust stage. This pipeline can, if you merge the merge request on the master branch or the default branch, this pipeline can also still run all these test scanners, but then will deploy typically to a staging or production environment after that. Within the merge request, developers see, as I mentioned before, they see immediately a report of the found vulnerabilities. So here you see what a developer can see in GitLab. The merge request will show you if the merge request needs to be approved. In this case, you see approvals from different teams like project management or quality assurance. But you can also have automated approvals where you can say, hey, if too many vulnerabilities are found of a certain type, then it automatically requires an additional approval from an InfoSec team, for example. Or you can say that the SAST scanner is automatically approving if no specific new vulnerabilities are being found. Something like that is also configurable. If we drop down, here you see this drop down. If you drop these down, then you can see the details of these vulnerabilities. You can see immediately what vulnerabilities are being found, and you can also click on each of these vulnerabilities to see what's happening. So these, as a developer, as I said, you can immediately see within the context of the merge request. Also, if pipelines are failing, is also visible in this merge request. So you can see immediately which vulnerabilities there are and how you could possibly fix them. You can look into the details of a vulnerability, and you see immediately where it is located, where it is found, what the description is, and from there you can immediately take action. One action is, of course, to add a new commit to the same branch or the same merge request to fix this, but you can also dismiss it, add a comment why you want to dismiss this, or you can create an issue, and in the issue you can discuss, for example, with InfoSec, how to best resolve this issue. For SAST scanners, we have a special feature in it as well. We call it training material. So in this training module, you will automatically learn about this vulnerability and how to resolve it in your code. Gives you hints and gives you best ways to prevent or avoid these situations. And for dependency scanning and container scanning, you often have in the CVE database the version in which the vulnerability is fixed. And from that, the dependency scanner and the container scanning take the new version, and they can automatically resolve this vulnerability through a merge request, where they will upgrade the version number of that dependency to a non-vulnerable version. That way you can simply click and it will automatically create a merge request with a suggestion on how to fix this. Cool. And let me have a quick check on the questions again. So what is a review app? Now, a review app is a deployment of your application, for example, on a Kubernetes cluster where your application is deployed in that Kubernetes cluster on a temporary basis. So it's only deployed during the merge request. And then you have an immediate test environment available in your merge request that is being cleaned up after the merge request is merged. Another question is GitLab equipped with the tooling necessary to guarantee SLSA levels 2 and 3 for software delivery, lifecycle governance, assurance, and to use binary authorization at the deployment end? I'm not sure what SLSA levels are. So this is for me, this is a bit of a difficult question for me, which I can't answer at the moment. So I'm going to take this one offline. I might come back to this in a follow-up or something. Is the InfoSec checks basically InfoSec tests added, built, and test step of the pipeline? I'm not sure how to see this question. If I interpret it correctly, then I would say that the InfoSec teams are basically smaller teams in a larger organization that have to manage vulnerabilities from many teams, and they typically assess applications, for example, before they go to production. And at the moment, that often happens way after a sprint has ended. What you want to avoid is that deployments are delayed due to InfoSec teams are fully flooded with so many requests. So what you want to do is you want to automate as much as possible, and you want to take as many vulnerabilities as early as possible, rather than leaving that until the end. So if you can already resolve a lot of vulnerabilities before it even leaves your merge request, then InfoSec teams have way less work to do, and they can focus on the more important stuff. Hope that answers your question. Let's continue because we have still some ground to cover. Now we have seen what developers can do to resolve vulnerabilities, but also let's look at what happens when a merge request is merged and what you can do then and what you can see then. So first of all, there is this security dashboard in the main menu of GitLab, where you can configure your own security dashboard. So you can select which projects you want to add in this dashboard, and then you can see from this group of projects how the vulnerabilities look out over time, and you can even see a project security status. Projects are rated based on the amount of vulnerabilities, and you get a status, and you see what projects are in that status, and you can also zoom in on that. This dashboard is meant for security directors or CISOs or something like that. So you have like an aggregated view, but you can also see then how it improves over time. If you are in InfoSec teams and you want to list create a vulnerability report for a group of projects, you can use this vulnerability report, which is also in that security section. And here you can see per type of vulnerability, what is found in that group of projects, in that specific group of projects, by which tool it is found, what the description is. So here you have your tools like the developer has on the merge request level, how to manage and triage these vulnerabilities. Project level, then you also have specific tools on vulnerability dashboards and vulnerability management. Again, you can see over time how things improve, and also you have this same vulnerability dashboard where you can filter on vulnerabilities and select the vulnerability and triage it. Also here you can resolve it, dismiss it, you can set the status on this vulnerability report. You can also select, for example, all vulnerabilities that are open for triage, and you can then select a few and immediately dismiss them in bulk. You can also go into the details of it and resolve it there. Cool. That's on vulnerability level, vulnerability management for security teams or, for example, product owners that have to do vulnerability management or triage at project level. But you also can automate things, and that's the compliance information. Compliance information helps in being compliant to certain standards, but also helps in automating InfoSec workflows in your project. Oh, I see it, my microphone. Let me switch to another microphone then. That sometimes happens, I must say. Thanks for telling me that. So this must be better in my audio quality. Sorry for that. Cool. Now, what I just mentioned is that you have these vulnerability reports and vulnerability dashboards on project level and on instance level. On instance level, you can create your own dashboards based on the projects you want to see. But you can also dive into project or group level where you see the group, all the projects within that group or the vulnerabilities within a project. These tools are typically aimed at InfoSec teams, CISOs, compliance people, or product owners, for example, that want to have overviews of all the vulnerabilities found. On the compliance part, yeah, you want to be compliant, but also you want to possibly automate certain workflows. So let's go into this. Now, if you have a large instance, or if you are in an area where compliance is very important, then GitLab can help you there too. We have security and compliance already built in. A single permission model within the entire application, where user authentication and also authorization is enforceable and consistent. So there's no need to manage multiple auth schemas across multiple applications. We can, of course, also connect to your local LDAP or whatever. Also single sign-on as possible. There's a lot of user management options in GitLab. Yeah. The idea here is that you want to verify compliance in less time, and you want to know what's happening within your development organization. One second. The GitLab enables compliance without friction. So we have security products built into our system. GitLab is a secure application, and we help our customers securely and managing their software development life cycles. So GitLab itself is, of course, compliant with many things, but we also can help you become compliant to, for example, HIPAA, GDPR, SOC, etc. How does it look like a little bit? In a compliance framework, you can say, okay, what is your policy? How does your policy look like? Which rules do we have to comply to? Which jobs have to run in which situations, etc. So that's all in your policy management. Then you add that to certain workflows, and these workflows you apply them to projects, and these projects are then bound to those workflows, and they will automatically be bound to your pipelines. And yeah, once you have your pipeline automatically run certain jobs, your audit management will find activities in the log files, etc., to prove adherence to compliance rules. Yeah. How does this policy management look like? We, for example, have merge request approvals in there, so you can enforce merge request approvals based on SAS scanner results, where the SAS scanner will automatically approve when there's nothing found based on the policy. Or you can have scan result policies where you say, okay, this is the result of your security scanner, and if so many critical vulnerabilities are found, or more than 0, for example, then inform an InfoSec, and you require an InfoSec approval. Things like that. Credentials inventory, keep track of all the credentials that can be used to access GitLab self-managed instance. So we have ways of using, for example, HashiCorp Vault, where you can store all your credentials in a centralized way, so that it's not in GitLab, or that it's not in the code, even worse. We can also make policies of that. We can have push rules where people can only push against with certain rules in place. Different possibilities that we have to help you be compliant. Once the policies and rules are defined based on certain compliance frameworks, you need a way to enforce these policies. Compliance controls and automation of compliance workflow focus on enforcing policies and separation of duties while reducing overall risk. So you can see that GitLab offers the ability to create templates to enforce rules and policies. These project templates can be applied to groups, and all projects in that group have to use that project template. To expand on those, GitLab offers also compliance framework project templates where you can create projects with issues that map to specific audit protocols, so you can help maintain an audit trail and manage compliance programs. GitLab also offers compliance framework project labels, where you can enable common compliance settings to be applied to projects with a specific framework label. So how does it look a little bit? Well, first of all, you define your compliance frameworks and your required CI jobs based on specific compliance. ISO is a compliance certificate, most say, and SOC 2 is not a certificate, but it's at least a label that you get. And then you apply these, if you assign project with a certain label, for example, ISO label, and then automatically the project A is, if it runs a pipeline, automatically SAST and DAST scans are added to the test stage based on the compliance framework label. Here you can see it. So here you see configure that ISO requires SAST and DAST jobs. Then you apply this label and you'll see the SAST and DAST scans being added. As an auditor, you want to see and manage what happens. We do a lot of audit events. For example, project and group actions, sharing options, permissions, approvals, logins, etc. And we can even stream audit logging events to external systems. And we also log everything within our GitLab instance where you can see it. With that, GitLab answers questions with GitLab's audit events that aims to satisfy organizational audit logging requirements with UI or via API. GitLab also gives you a compliance dashboard that aims to provide compliance insights in a consolidated view with all relevant compliance signals, such as the segregation of duty, framework compliance, license compliance, pipeline, and merge request results. So currently, the dashboard focuses on most recently merged merge request activity. This is an example of this compliance dashboard. So you see the merge requests that have been created and the results with it. So you see, okay, this is all green, but here you see that it has to be approved by people, etc. So you see in one overview on compliance level, have these projects been compliant? I also saw a question on tutorials and workshops. So we do have trainings. These trainings are not free, so you can order them. Security trainings or DevOps fundamental trainings are interesting here. This is our professional services department that can help you order these trainings. There is also on our docs page tutorials on security and DevSecOps. Right? You can find them on docs.gitlab.com. And we do have workshops sometimes. I'm not sure if it's also on DevSecOps and if they are free. If you are a customer and you have a customer success manager assigned, I would recommend asking your customer success manager for this. Cool. That were all the slides. So allow me to launch the poll for now, and then I can move on and answer more of your questions. But first I will launch the poll. Thanks for answering this. It helps us in making our webinars more useful and more helpful for you guys. We run these webinars on a monthly basis. Every month we have different topics that we run. I think it's even 3 or 4 webinars each month. that can range from advanced CI/CD pipelines to topics like DevSecOps. So please check our handbook on these webinars. DevSecOps is definitely a topic that will be repeated more often. Definitely also with the questions that you all ask, we might improve our slide stack for the next time. Cool. I see a huge percentage already answered this question, so thanks for that. We're about half now. Yeah. I'm going to enter the poll in 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Cool. Thanks all for answering that. Now let's focus on all the questions that are asked. I'm going through them from top to bottom. If there are any more questions, simply add them in the Q&A section, and I will try to answer them. We have plenty of time, so it should be enough time to answer all your questions. The SLSA, I saw someone telling me what that was later on. SLSA, GitHub, SLSA implementation. I have to really, I clicked the link now, which I maybe shouldn't do. I have to really look into that, what SLSA means and how that's implemented. I will try to add this to the follow-up email that is sent later on. I'm putting it away now. If Dust is against a running application, shouldn't there be a deploy job in your pipeline? The Dust scanning is running against the review app, and the review app is deployed in your pipeline. It's one of the slides. Maybe I can get to that one. Yeah, this is here. So this is the review app, which is deployed here. And in this slide, you see here is the job that will deploy the review app. And this is a special deploy job. So there's certainly a deploy job, which deploys a job to a review environment. So the environment is created, and that's called review app, and mostly with a sort of random number based on the pipeline number or the commit or something, which is then deployed to Kubernetes most likely, or something else. It can be anything. So that's done in the review stage. And if you merge the merge request with auto DevOps enabled, then in the pipeline that is triggered after the merge request is merged, it will automatically also destroy the review app and clean everything up. Please provide the documentation link to learn about DevSecOps. Yeah, okay. Let me do that in the last bit of this webinar, so I have a bit of time to look that one up. I can do that definitely. How to leverage and integrate SAST tools, so Fortify, Dust Web Inspector. Yeah, I see a lot of tools: Fortify, Web Inspect, Black Duck, Sonatype, Lifecycle. You have to look into documentation if there is integrations with these third-party tools. I know that you can integrate third-party tools in GitLab Ultimate, where you should deliver a specific file in the job. So you have a job that will kick the test, for example, in Fortify or in Web Inspect. These tools will most likely return a result of that scan, of that test. And if you can modify that result in a way that it's given a file, a JSON formatted file that the SAST scanning can read, then that file is being picked up by the job result, and it's how you say it, it's scanned, and the results of that JSON file are then added to the vulnerability report. So that way you can indeed include third-party tools into your job pipeline. We are definitely working on it to make these integrations even more easy. That's work in progress at the moment. I'm not sure when that's coming, but that's at least the focus of last fiscal year, and it will continue to be our focus in the next. On any sample project, demo projects, I need to follow up on that afterwards. I have no links available at the moment, but I can definitely try and find some. We do have tutorials, but there might also be a demo project or a project template in GitLab available. Are there any plans to support VEX and CSAF in GitLab? I have no clue what VEX and CSAF are. A vulnerability review has typically a longer life cycle than a single merge request. That is definitely true. So within the merge request, the idea is to capture there or to catch there most of the vulnerabilities. So many vulnerabilities, they can be resolved by, for example, using this resolve by merge request option, where you immediately increase the version number of the dependency, or when you can apply a simple code snippet to fix a SAST vulnerability, and there in that way you are able to take all the easy stuff, all the low-hanging fruit away from the InfoSec teams. And if you can get all the easy to solve vulnerabilities out of the list, then what remains in the vulnerability report afterwards, after the merge request has merged, is the list of vulnerabilities that are difficult or more difficult to resolve, where you need indeed InfoSec to help you out in finding a good solution. So yeah, I agree. There are many vulnerabilities that are typically have a longer life cycle than a single merge request, and that's where you use the vulnerability dashboard. That's where you use the vulnerability reports on project level to fix that. And I would definitely recommend create a ticket of these vulnerabilities to guide the review life cycle. And this out of the box, GitLab will create a GitLab issue, of course, but you can also create Jira issues. If you have Jira issue integration enabled in GitLab, then you can use the vulnerability to create an issue in Jira automatically. So how to use third-party tools? I just mentioned that. So there are some integrations, and as I said, if you can make the report that's coming out of these tests as GitLab expects them, then they will automatically be picked up. And we are working on third-party integrations. Can we offer a view of how many pipelines are implementing the security feature? Yeah, pipelines is difficult. So projects, maybe there is a DevOps report on instance level or on group level, where you can indeed see if groups or projects are using DevOps or DevSecOps tools, security scanners. It's a bit rough, so you only see if at least one or more, but you don't see how many projects are using security features, and it's not very fine-grained in which security features are being used. So yeah, you see a little bit of it, but not very detailed, unfortunately. That's something maybe we could could add in the future. If you're using compliance pipelines, though, where you say, hey, these in this compliance pipeline, these jobs are mandatory for every project, and you apply these compliance pipelines to your top-level groups, then you are 100% sure that all projects in that group automatically use these jobs. Are the SAST and DAST jobs added by the compliance framework language agnostic? The SAST and DAST jobs are already language agnostic by default, so they try to determine what type of language you are using and then run it accordingly. That's built into templates that we offer in GitLab. So if you go, even if you have a self-managed instance, if you go into GitLab, then there are certain templates that you can include in your pipeline. That's all documented. So I'll try to add documentation links to your to the follow-up email, where you can simply use a template, for example, job/SAST scanning or something, and that is language agnostic by itself. And what languages are supported is documented in our documentation page. So normally there's no additional configuration required to make it language agnostic. Yeah, third party, I've already answered that. Most of this is only available in the Ultimate, right? So yes, that's true. Definitely the compliance part and the vulnerability reports are Ultimate features. Even on the free instance, we now do support many of the security scans. So you can run many of the security scans even in a free version, the community edition. And what happens then is, for example, if you run a secret detector, then the job will run. It will output a JSON file with the report of your vulnerabilities, and you have to then manually check the vulnerability of the JSON file if there's anything happening. So you can definitely run the scanners already and create output, but you have to then manually look into the output, or you have to write something yourself that will take the output and read it automated in an automated way. Yeah, how to use Fortify SAST in GitLab. I'm not sure how to do that. It does make sense to search in our docs if there is a Fortify integration with GitLab. Otherwise, if you are able to trigger Fortify from a GitLab build job through an API call or something and retrieve the results from it, and if you're able then to modify these results into a format that GitLab can read, then that's how an integration should work. But I'm not sure if there's already something. Then the next question, I did find a GitLab vision page for supply chain security, including SLSA here. Yeah, okay. I'm going to look into that after the webinar, find out what this SLSA and everything is, and then I will add that to the email. Sorry about that. It's the charm of working from home, I think. Okay, is it correct that you don't have to use GitLab's own review app to enable the DAST job? The DAST job is configurable to point at any URL. Yeah, so indeed, the DAST job is configurable to point at any URL. That's definitely true. Therefore, you don't need to use GitLab's own review app. You can write your own deploy app that will deploy a review or test environment where your DAST job is then running against. Yeah, how to use DAST solution web inspect like Fortify. I'm not sure how that integrates, if it integrates. As I say, it also depends on the third-party tool, if it's allowing us to integrate. Let me follow up on that too. How to use open source software scanning. And is that supposed to be license scanning? I'm not sure. OSS scanning. it sounds like license compliance scanning. So what license compliance scanning does is it will scan all your libraries and all your source code in your repository and will check what license is being used. And it will give you an overview of all your licenses. And then after that, you can set a policy on that license. So you can say this license is allowed, this license is not allowed, etc. If you run your license scan again the next time, and if you have a dependency that is using one of the blocked licenses, it will trigger a new vulnerability. And that's also something that will run, as you can see here, early on in the test stage. Hopefully I have answered that one too. How to use dashboard in GitLab for deploying the apps build artifacts to various environments. I can't see how this relates to security. So, and I'm not sure how to answer this question either. For me, this doesn't really sound like a security thing. So we do have environments. You can define them your own. So the review environment, but also production and staging environments. We have our environments page and our release page where you can see what is deployed where, if you're using a deployed job with an environment set. I want to leave it at that. Yeah, facts is then vulnerability exchange. I will check that later on. Do we need to run the CI/CD pipeline for security scans for I'm not sure what's saying there, every commit? And merge to any branch or default branch. What do you recommend? I definitely recommend to run all the security scans, or as many as you can, on the merge request branch, and then also on the main branch, on the default branch. The default branch runs after you've merged, and yeah, then you run it again on what may have been changed on that default branch. So I would run them as soon as possible. In DevOps and also in CI/CD, the goal is to have early feedback, but yeah, this adds also a lot of extra additional feedback on your security status. Many of these things, especially dependency and SAST scanning, if you know immediately, hey, this dependency is wrong, or hey, I'm doing this code, but it's against our code quality standards, then you can immediately fix it before you are starting to use it everywhere. And then it's a lot more time to fix things. So I would definitely recommend, and our Auto DevOps template also runs all these secure scanners in the test stage for both the merge request as well as the default branch. Cool. Are we close to time? I think there's one question left that I can have a look at. Is there any live example or GitHub repository to understand all this pipeline with DevSecOps features? Yeah, that question was also earlier. If there's anything on tutorials or things like that, I will look that up and make sure that's in the follow-up email. Yeah, a lot of questions. Thank you for that. I've learned things too, which I'm grateful for. And I said I will add a few of these things to the follow-up email. And then all is left to thank you all for joining and for your time, and hope to see you sometime next in a new webinar that we run. Thank you and have a good day.